Over to you, Harsh.
Thank you. So, good evening and welcome you all again. Thank you for taking your time and joining with us. I assure you, you will have a great experience and you will learn lot many things today. So, before we move further, I request everyone to keep your video on so that we can have a very personalized and a interactive session. Please, everyone. Okay, thank you for cooperating. So introducing myself, I am Harsha, student of SVNIT Surat and currently pursuing mechanical engineering with Brats. From mechanical engineering and interning with Brats. So for me, Brats is one of the best platform for students to learn, grow, develop and mold themselves to stand in the corporate world. It helps the students to work on some real life marketing problems and to come up with the solutions. So let's see the message of our Captain Brats, Mr. Suresh sir. Thank you.
Yeah. But one side, if I'm seeing, India is the largest demographic education hub. Still, there are about 4 lakhs of students going abroad for higher education year on year. But one side, if I'm seeing, a lot of Indians are actually leading global corporates. That's a beauty of Indian talent which needs to be pulled out. Brats. Now, Brats, what is Brats? Everybody's hearing, you need to know what is Brats. Brats is brands, research, advertising, technology, and strategies. What we are actually trying to do out here. So our last 3 years research developed this platform to connect industry and institutions. What are platforms we actually need to connect? We want you to get ready for the industry while you're in the institute itself. You are thoroughly going through your curriculums, but there are a lot of real-time experiences, case studies, live projects, courses maybe, and that has to be enrolled into your internships, otherwise recruitments. That's what we are here to bring out through your Brats. My name is Suresh Kumar Kurapati and I'm the captain for Brats. We already have about 1,000 plus students associated with us and a lot of students actually helping us to grow within the campuses, being our campus ambassadors. That's what we look forward to, and I welcome you all and let's grow together. Thank you so much. Goodbye.
Thank you, sir. So, moving on to our speaker. Today, our speaker is Mr. Ashish Singh, who is a data scientist and a machine learning engineer with more than 7 years of experiences in building data-driven solutions in engineering and machine learning focused companies. So, sir is skilled in deep learning, AI, and data science. He is great at analyzing the entire solution of the problem while taking into account the time, economic resources, and the business requirements. He is currently working as a data scientist at Kansai. So as a mechanical engineer, I am very excited for this session to learn about AI and machine learning. So thank you, sir, for taking your time and guiding us here. Anyone who has any questions or any doubt, feel free to ask in the chat box and the YouTube audience can put up their questions in the comment section. Over to you, sir.
Thanks, Harsh. Thanks for this pleasant introduction. Hello, everyone. This is Ashish here. And as Harsh mentioned, I'm a data scientist at Kansai. Thanks a lot for joining in. I appreciate your time, and I hope I won't bore you. And also, thanks a lot for inviting me at Brats webinar. I'm privileged to be here. So I've been a data science practitioner from last 7 years. And in my journey, I have worked on solving multiple problems in data science. And I've also witnessed the growth of data science, because what it was 6 years before and what it is now. So today I'll be talking about AI ML, and we'll also be happy to take some questions. So let me share my screen so that I can present. Give me a moment. Yeah, so are you guys able to see my screen? Is my screen visible?
Yes, sir. Yes.
Awesome. Thank you. Yeah. Yeah, so let's begin the journey with AI and ML, right? So foremost, we all have to understand that machine learning is like electricity. Like why I'm saying electricity, like today you can find electricity everywhere. Like you look around, you see your laptops, your mobiles, your tube lights, your fan, air condition, everything is working on electricity. And that is what machine learning is doing and will be doing in the next future. So let's see some examples to understand more. So I'll talk about healthcare first because I belong from healthcare industry. I'm myself working in solving a lot of problems in healthcare. So let's talk about machine learning today is solving problems of cancer diagnostics. You just think about, like, you have your cancer imagery here. You can see in the image, like there are some red lines and some green lines. So the machine learning model is able to understand what are cancerous and who are non-cancerous cells. I mean, just think about it. Like you don't need a cancer specialist for this, even though I will say that this is assistive in nature. So once it identifies, an expert will go and look at it. But in a way, it's a good thing to do, right? Then let's talk about facial recognition. I mean, we have seen this a lot. I mean, you post a picture in Facebook, Facebook will recommend or tag your friends. From where it's trying to identify your friends, it's facial recognition. You talk about Apple iPhones, right? So they have something where you look at the phone and then the phone unlocks. Why? It is recognizing your face. It's also AIML, right? We have seen a lot of voice assistants today, like Alexa, Siri. I mean, Alexa is something with whom you can chat, right? You can say, Alexa, what's the score right now? Or Alexa, what's the temperature right now? Alexa, can you sing a song? And it'll do that. Because this is what AIML is doing. It's trying to, solve a lot of problems. Then recommendation systems. We all have seen Netflix, right? So once you watch movies on Netflix, Netflix starts recommending you movies. And why it is good? Because yeah, your friends can also recommend you movies, but Netflix has a lot of variety of movies, and there are certain movies which you might not have seen or your friends might not have known about, but Netflix will recommend that to you. Self-driving cars. Yeah, we are hearing a lot about self-driving cars. So in a way, just think about it, like, right, like you have a self-driving car, you're just sitting there and the car is taking you to from one place to the another place. Amazing, right? Advertisement. So advertisement is something that we are seeing on a every day, right? I mean, you log into YouTube, you browse Google, you go to Facebook. I mean, you will see a lot of advertisements there. I mean, curated products for your choice, basically what you are looking for. And then games. Yeah, so why I mentioned AlphaGo is why we will visit this topic later in the slides, but just wanted to give you an introduction that Go is a very complicated game. It's more complicated than chess. So AlphaGo mastered this game. I won't say mastered this game, but learned to play it better than anyone else. And then we have stock market. We all know that the stock market also uses machine learning, artificial intelligence, and it's everywhere. I mean, if I talk about it, we'll just talk about an hour, like where machine learning is being used. It's being used everywhere, and if not everywhere, it will be used everywhere. So let's move on. So I always see this 500,000, right? So whenever I watch a YouTube video these days, I see 500,000. So what is this 500,000 like? So this 500,000 is data related jobs in the next 2 years. Isn't it amazing? I don't know from where they got this number 500,000, but even though it is like maybe 50% here and there, but then also it's a very good number, right? Like, but why in the next 2 years? I mean, what has happened in data in the last like 5 years or 10 years that we're talking about data related jobs? And I mean, why? So this is a very good question, right? So the answer is here. So let me give you a brief introduction of this chart. So this is an infographic I got from a website, a Visual Capitalist. It's showing us like how much data is generated in a day today. So look at the numbers, right? Like 500 million tweets are sent every day. 294 billion emails are sent every day. I mean, amazing numbers, right? Let's look at more numbers. 4 petabytes of data created by Facebook, right? 65 billion messages sent over WhatsApp. I mean, and I can go and go on. You can see like these 28 petabytes of data generated from wearable devices. 95 million photos and videos are shared on Instagram. And you look at a number there, 463. The 463 EB will be the data created every day by 2025. And now let me throw a number at you. Till 2005, the whole human history, the data was generated was only 10 EB. So from 0 to 2005, the total data generated was 10 EB. And we are talking about 50 times that data to be generated every day. I mean, I cannot calculate like multiplying it by 365 and then trying to see what bytes or whatever it is. And it is a hell lot of data, hell lot of data. So if there is a hell lot of data, then who will work with this data? You will need people who can understand or work or analyze or explore or do something on this data. And that's why data related jobs will be the futuristic thing, right? And with the advancement in technology today, we are having very high performance computer systems. We are having distributed systems, cloud computing, whatnot. So being in data will be something that would not only be interesting but also will drive a lot of things in future. So that's why that 500,000 number comes up these days a lot. But now we have spoken about a lot of what kind of things AI ML DL is doing, but do we understand what is AI ML DL? Like, what is artificial intelligence? What is machine learning? What is deep learning? Are they the same? Are they different? What are they? I mean, this is one question that will confuse a lot of people, right? Like, because we use this term interchangeably, right? And as the introduction, I wanted to make sure that people understand these concepts, right? Let's talk about artificial intelligence first. So I'll explain by examples. I won't throw in mathematical equations or codes or something like that. We'll do it later on sometimes. But today, let's just see examples and understand through it. So let's see, like this is a guy. Let's name him. Like his name is like Manoj, and Manoj is a sports lover, right? Like he went to his office, he came back, and he says, Alexa, what happened in IPL today? And there is this device Alexa in his sitting in his drawing room, right? So when this device heard Alexa will be a wake word. So wake word is something which will wake up the device. So for example, if my name is Ashish and someone calls me from behind Ashish, I'll just say, oh, what? Well, I'll move around, right? So it's the same wake word Alexa. So when he speaks wake word Alexa, what happened in IPL today? What Alexa does is it tries to understand what Manoj is saying, right? And then it uses its what kind of system is behind it, deep learning, artificial intelligence, machine learning. And what it does is it creates an output for Manoj and says RCB won the match. And why this is very interesting is because the match just ended 2 hours before. And even if you ask this question to any human being, he might not be able to tell the answer if he has not seen that match. So this is now very exciting, right? So nothing was programmed into Alexa that something has happened. So if I, for example, if I say, which is the highest mountain, like what is the highest mountain in the world? And you say Mount Everest, it is something that can be programmed. But here, this is something that has happened, and Alexa was able to retrieve this information by understanding what Manoj was saying. It's phenomenal. So here you can see that there's a device who's trying to do human-like activity, and that's what we call artificial intelligence. So inside artificial intelligence, it does whatever it can do, but its behavior is human-like, like self-driving cars, right? So if you sit in the car and say, drive me from Bangalore to Delhi, and the car does that, right? It's a human-like behavior. The same thing you will do with your friend, right? If you don't know driving and you have a friend who is a good driver, you will say, hey, can you take me to New Delhi from Bangalore? And you'll say, okay, just hop in. And then he will start the car and you will go with him, right? The same kind of behavior these systems are doing. It's like amazing. Now let's understand what is machine learning, right? So let's say that he's Ashok, and Ashok wants to learn about data science. So he's searching on Google that what is data science, and he gets a Wikipedia link on the first page of Google. He clicks on the link and spends some time on this page. So once he spends some time on the page, what does Google understand about this user? So Google understood that, okay, this guy had some question for which we generated some answers, and he took one answer, spent time in that. It means he was reading it. So the user got what it wanted. So it's kind of a machine is learning from a user behavior. You are understanding this, right? There can be a different behavior. For example, uh, Ashok goes and scrolls to page 2 or page 3 or page 4 and goes on. What does this infer? This infers that the user requirement was not satisfied. So Google, the machine will learn that, okay, whatever output I gave to Ashok, he was not satisfied with that. And maybe let's try to improve on it. So machine will learn and improve. Let's talk about deep learning. So there is this guy who has been assigned a very difficult task. So what is his task is he has to count how many number of cars, buses or trucks is passing on a road in the like 6 hours, for example, like from 12 to 6 p.m. But this guy is intelligent. What he does is he records everything in a video. So he puts his video camera on, records everything for 6 hours, right? Because it's very difficult to count cars and buses. You might want to take a water break or something like that. So how will you do that? So he records everything in a video and then processes this video through a deep learning network. And then he gets a report. Number of cars 250, buses 75, trucks 100. Now, do you think he needs to sit there for 6 hours? No, right? He can just put his video camera on 24 hours and this deep learning model will, calculate all the kind of things that he wants to do, like calculate number of cars, trucks, buses, etc. So here I've given you 3 different examples: artificial intelligence, machine learning, deep learning. But again, the question is, do you think they're overlapping somewhere? Like it's very difficult to understand and identify it, right? So now let's make it more simple. So just think about this chart, right? There's artificial intelligence. Inside this is machine learning and deep learning. So all deep learning is machine learning. All machine learning is artificial intelligence. And artificial intelligence is a human-like behavior. So it's an end-to-end thing, like a self-driving car or like a Alexa, where you give a command or an input and you get an output, polished output. Inside it, Alexa might be using machine learning, it might be using deep learning, it might be using n number of things, right? But you don't have to worry about that. It's an end-to-end thing. So artificial intelligence is like intelligent machines that think and act like human beings. Machine learning is a system which learn things without being programmed to do so. And deep learning is systems which learn things like human brains using artificial neural networks. This is just a technique, like the algorithms are different. So the only difference between ML and DL is, right, ML and DL both does the same thing, but DL has a very complex algorithms. It needs a lot of data to train. It needs a lot of computing power to train. And it's very popular these days because, as I mentioned that, right, earlier machine learning was more popular, but now deep learning are more popular because the processing power and the data is more today. So now you have now we have mobile phones having like 8 GB or 16 GB RAM, and 10 years, 12 years, 20 years back we only had computers having a 1 GB of RAM. So the computing power has increased a lot, and this has given deep learning a great lift. But then why people are not only using deep learning, why they are using ML, machine learning as well today? Because of a lot of factors. Because machine learning is explainable. I mean, you can explain the output. Deep learning is black box. You put in the input, you get the output, which is good, but you won't be able to explain that. And for some of the things, like for example, you used your credit card and it got declined. The bank said it was a fraud kind of a transaction, but you said no, it was me who was doing it. So how can you quantify that like it's a fraud? So the bank has to explain it. So in order to explain it, it has to use machine learning, because deep learning might not be able to explain it very properly, but machine learning has a lot of things to explain, and let's not go into detail because it will confuse people a lot. So let's just put it this way, that there's a deep learning, on top of it is a machine learning, then artificial intelligence is a human like behavior shown by a machine. So let's see some more examples. For example, better marketing techniques. So, which category it will fall into. Better marketing techniques, machine learning. Hyper intelligent personal assistants, which category it will fall into. So for just think about it, like it is hyper intelligent personal assistant. So it will need a lot of data to train, as a personal assistant like Alexa or Siri. You have a lot to understand and consume a lot of data, train on it. And so this will be categorized into deep learning, and like something like detecting crimes before they happen. So this is an end-to-end solution, right? So it's an artificial intelligence. So just some examples to just go through the concepts that we learned today. But now a very amazing question is, Leaks, right? Are they better than humans? So I think most of you would be just thinking, right? Like, oh, are they better than humans? So let's see like what it is. So my answer would be it depends. It depends upon the kind of problem we are solving. It depends upon the kind of, things we are using, the data we are using. Why? Let's just look at a very interesting example. So this was a cricket match being played between India and Bangladesh in Bangalore. I don't remember the date, but the thing was Bangladesh needed 2 runs to win in one ball. And we can see the Indian captain at that time, MS Dhoni. What he did was he removed his right gloves in advance. So he was detecting something before it happens, right? So just let's process what is going on here. So Dhoni, as a captain of India, and he has played a lot of matches and has a lot of experience under his belt, right? So he would have told the bowler that, okay, you have to bowl a specific delivery, right? And then he will set his fielders at specific points so that they can like save 2 runs, yeah, because we don't have to lose, right? And then he analyzes the risk and understands that there can be a scenario in which when the batsman misses the ball, he can run for a single. And if he's wearing his gloves, that might not give him that extra split second to make the batsman run out. So he analyzed the risk, and then he said, okay, there might be a 1% chance of this happening, so let me be ready for it. And this is what like the machines will do. They cover all the points together, right? So MSD did the same thing here. And then what happened was he was able to run out the batsman by that split second, right? Resulting in a win. So yes, so domain expertise also matters, right? I mean, machine can learn with so much of data around, but if humans have that domain expertise of that subject, then they are better. And I'll give you an example in which you will also say, yeah, human will be better than machines. So let's see some of those examples. So yeah, first let's see what might be an example where human might not be better. So it's something like recommendation or advertising, or because see, just think about it, right? Like if you have to recommend a movie to me, will you be able to do it? No, right? I mean, yeah, you can look at my Facebook profile, my LinkedIn profile, understand, okay, what I'm interested in, what I want to do. Maybe if I'm your friend, you know more about me, right? But you will be able to recommend a movie to me. Maybe I have watched it already, right? So I won't be watching it again. So Netflix will do a better job in recommendation, like recommending me movies. Why? Because Netflix also knows what kind of movies I've watched on its platform, right? And what kind of movies I know. Maybe there's a movie in some different language which it has just translated, which might suit my taste, which you might not know. It's just that the machines can crunch a lot of data. And if the data is in structured form, like when I say structured, let's not think about structured and unstructured databases. No, structured means that the data is in numerical form, a categorical form, something which a machine spits out whenever it runs, right? But there are other kinds of data, like a handwriting. So human can read handwriting better than machines. You will agree to me, right? Another thing, human will be able to identify cats and dogs better in an image, right? Other than like machine can also recognize cats and dogs, but human can do a better job at it. Why? Because we as a human being, we try to we can say how things taste. We have our sense organs, right? So we can see things, we can hear things. So if we have to do speech recognition, we will do better than machine. We can do image recognition better than machines. We can do, so for example, I just showed you that image of cancer diagnostics, right? So a good doctor will be able to beat machine in that. I mean, it's true, because he's an expert, he has been through lots and lots of things. But what machine can do is it's scalable. So for example, if you give me a job of identifying cats and dogs in image, I can do 1,000 image a day, right? But machine can do 1 million or maybe 1 billion images a day. So and there it wins from me, right? So there is like trade-offs in this scenario. So let's look at another interesting fact. So I spoke about AlphaGo, right? So Go is a game which is played in Southeast Asia a lot. I mean, China, Korea. And it's a very difficult game. I mean, it's so difficult that people say that like a Go player has to, practice a lot, and he has to have a deep understanding, a very high IQ and things like that. So there was a Go champion. So this guy Lee Sedol was a 18-time world champion, and he was unbeatable at that time. And then Google came up with a DeepMind algorithm, and they had a match between Lee Sedol and AlphaGo. This was a 5-game match, which AlphaGo won 4-1. So I mean, there was a match in which Lee Sedol won as well. But this is it was on Netflix also. You might find it on YouTube as well. So please go and watch this documentary. It will give you a lot of insight about how these things work, and why did AlphaGo lose? Because if something has been trained to win, why didn't it win 5-0? Why it lost one game? So it's very insightful movie. Please go and watch this if you have interest. Yeah. So now let's discuss a bit of small theory about machine learning, right? I mean, it's a machine learning webinar, so we should actually go from here, understanding machine learning, and have a good definition of it. So there's a guy called Arthur Samuel in 1959. He gave a one-line definition of machine learning, saying that field of study that gives computers the ability to learn without being explicitly programmed. So here what he's saying that, so what happens is when we work with computers, we do a program, we make a program, and then we give the data, the computer executes the program sequentially and gives us an output. But here he was talking about a concept in which we are not programming. The computer is able to learn it. And a very rhyming definition was given by Tom. He says that a computer program is said to learn from experience E with respect to some task T and some performance measure P if its performance on T as measured by P improves with experience E. It's like a poem, right? But it's giving you a good sense, because you're learning from experience E with respect to some task T, that is maybe identifying cats and dogs or some, whatever it is. And then once you identify, you measure your performance, that how many cats you were able to identify, right? And if you are, so for example, if I give you just 2 images of cat and dog, and you have never seen a cat and dog, it might be difficult for you to identify a pug, because you will confuse whether it's a cat or a dog. So a computer will also do the same thing. But he says if its performance on T as measured by P improves with experience E. So what he's saying is that initially the model or machine learning will make mistakes, but as it learns from more and more data, its performance will keep increasing. Let's see an example. So like traditional programming, if I have to calculate a square root of a number, right? So I will give a data, I will write a program how to calculate square root, and then the computer will take the data, execute the program, give me an output. So if I give 4, it will give me 2. But what machine learning says I don't want your programming skills. You give me data and you give me the output. You give me like 1 becomes 1, 2 becomes 1.414, 4 becomes 2, 9 becomes 3, 16 becomes 4. You give me all of those things. I'll figure out how it is happening. And then tomorrow, if I learn on everything, and then you say, okay, tell me the square root of 100, I will say 10. So the more data you will give, the more accurate I would be. I'll give you an example. So for example, you only gave 1 data, that the square root of 1 is 1, right? The computer learned square root of 1 is 1. So now you are saying, tell me the square root of 2. The computer won't be able to tell you, right? Because it only knows 1 is 1. So it might give you an answer 2 is 2. But if you give it like 100, 200 records of square root, then it figures out how it's happening, and it will give you a correct answer. If not correct, near about correct. More data, more accuracy. So let's now look at some examples as well. Like how would a self-learning car react to a traffic signal? What it would do. So for example, self-learning car is there. There's a video camera on top of it. The camera is reading what is happening around, streaming it to its machine learning or deep learning interface. So when it will see this image, it will try to figure out, can I see a traffic post here? Because see, there are a lot of posts here. There are like 4 or 5 posts here, right? You can see there are some electric poles as well. So first it has to identify whether there's a traffic post here or not. It's the first task, right? So it takes in this video stream, identifies the post. When it identifies the traffic post, it has to identify, okay, which part of this traffic post is a traffic signal. because it can be in different shapes. We have seen, right? Somewhere it will be center, top, might be tilted. So then it has to identify the traffic signal. Once it does that, it has to identify where is the traffic light segment in it. Once it identifies the traffic light segment and figure finds out whether it is green, red, or yellow, then it takes the desired action. So this is how, it's not one model or one thing that is happening here. There are multiple things. We have to break down task into small components. Each component is doing its job, right? And once everything comes together, it becomes a kind of feature. Like we can say one of the feature of self-learning car is to react to a traffic signal based on the green light or the red light, things like that. So let's look at some use cases in different domains today, right? Like as we discussed that it's everywhere, right? Like let's see some of examples of that. Like marketing. So marketing has a lot of problems, right? Like customer churn prediction. So if you have a system and you have like 100,000 users in it, you want to, so the main essence of your business is to get more users, lose less users, right? So if you are able to understand that, okay, in the next 1 month, these are the list of users that we might lose, then you can take some intervention. In today's world also, you would see, right? I mean, companies will send you coupons or some things to again get back into their system. It's because they can identify that, okay, you are one of those people who might go to another platform or might go to another product or might not use them. So it's better to intervene early. Then it's about predicting purchases. For example, Diwali season is going to start, right? Even though we're in the COVID world, but Diwali, they will, a lot of offers goes on in e-commerce websites, and they have to predict the purchases as well, because they have to take care of their inventory, stocks, inventory, everything, right? So if they're able to predict things properly, they can make more money. Because, for example, if you predicted you are only able to sell 100 items and if 1,000 items orders comes, then you are making a loss. On the other hand, if you thought that 1,000 items are getting sold and you bought 1,000 items and only 100 items get sold, so you have to bear the cost of 900 items. So it's a both way thing, right? So if you are able to predict this properly, you're going to make more profits. Then customer segmentation. So you want to understand how many types of customers are there in your system, right? If you can segment them properly, you can have different offers. For example, in e-commerce, there can be a customer segment who wants to buy books. Other segments wants to buy clothes, for example. Some segments will want to buy electronics. So if you want to identify these customer segments, then you can curate marketing materials for them, maybe in emails or offers. Then same like in business as well. There are a lot of things that happens in business. Let's take, for example, banks. So in banks, a lot of problem that they face is fraud things. So if a business is able to detect anomalous events in advance, it's going to benefit them, right? Then again, demand forecasting, chatbots. So for example, if there's you can see some of the traveling companies right now are having chatbots. So they will send you everything on WhatsApp, and then when they will ask you, okay, press 1 to get this answer, press 2 to get this answer. So they're trying, because earlier they will have to have a customer service guy sitting for you to answer the questions day in and day night. But now they have automated some process, so that even in the weird hours, if you have some query, that can be answered. A lot of things has to be done in chatbots. I mean, they are not, like, we cannot say that they're ideal chatbots, but yeah, it's a good start. Also in healthcare, we have all seen that when COVID came in, it was very unfortunate, but it saw that the healthcare was on a verge of breakage, right? So demand planning, efficiency and things like that has to be taken care of. Then we always want better care for patients. And there are a lot of work also going on, like image detection for X-ray and everything, to identify the onset of disease. And there are a lot of things here, right? Looking at your lab results for the last 10 years, or like whatever history we have, can we predict an onset of a new disease and things like that. So and all other things like make it HR, human resource, or cloud, or anything. There are lots and lots of use cases in every field for machine learning. So now let's let me give you a glimpse of what kind of roles are there in data science, right? Because here we are talking about data science, so we need to understand like what kind of things can be done in data science. So first role, is data engineering, which is a very pivotal role, because as we know that a huge amount of data is available. So data engineers play with that data, clean that data, build pipelines from that data, architect that data, scale on that data, because earlier the data was very less in number, size, so it was easy to play around with it. But now with humongous amount of data, it needs some skill to work with the data. And if you can get the right skill, then you can be a very super data engineer. The other most popular segment is data scientist or machine learning engineer. So these are the people who will go and create solutions using machine learning, deep learning techniques. We'll put the things into production so that it runs. So when the data is being available to them from data engineers, they will work on that data to solve that problem. Then we have another role, which is data analyst or data visualization engineer, who creates dashboards, create visualization. They consume the data. They might use the data from data engineering. They might use the data which has been provided by data scientists, model outputs. They'll create and curate a dashboard that can be used. Yeah, guys. So, this was a brief introduction about AI ML. Happy to answer any of your questions, or if you want to know more, yeah, let me know. Yeah.
Thank you, sir. So it was a very good session. So you explained about how this all things are interrelated, how the domains of AI, ML and DL, and its usefulness in medical and business development and its roles. It was a very informative session. So we have some questions. So Prachi Pandey, her question is, sir, yes, sir, which language is best for data science?
So I would say that don't get stuck on languages. Try to get the concepts, because language might come, something new might come tomorrow. But today, if you look at things, R and Python are two of the programming languages which are being used a lot in machine learning. And they are interchangeable in a sense that if you can understand things in Python, for example, it won't take a lot of time to do the same stuff in R. So first and foremost, you can master any one of those languages. Yeah.
Okay, thank you, sir. So next question is from V. Adityan. So, sir, where can we find the data to feed to machine for machine learning?
So it depends on the kind of problem you are solving. So let me give you some example, right? So for example, if you are trying to experiment on building a solution to identify cats and dogs, you can just go to Google Images, download all the images and use it. If you want to work on some problems like maybe some healthcare related problems, or maybe some financial related problems, so you can go to some open source places. Even Kaggle will provide you some data to start working on it. So you can download that Kaggle data and work on it. So and just make sure that whenever you work with data, you look at the licenses, whether that data can be used by personal usage or not, or whether you can put that data into GitHub repository of yours or not. So just look at the terms and condition of the data usage policy, and then you can use it. But if you can generate your own data, or for example, you have your Facebook, you run your Facebook ads and you generate a lot of data from it, you use it, you're free to use that data. Yeah.
Yes, sir. Thank you. So the next question is from same V. Adityan. So, sir, which role is stable in job market, and what is the opportunity in India?
So there is a lot of opportunity in India. So if you just go to LinkedIn and just search for data scientist jobs, you will see a lot of jobs coming up there. But the thing is, don't go for stability. Look for things that you want to do. For example, you can, if you like designing dashboards and working on it, you can be a very good data visualization engineer. If you want to build models to solve problems, you can be a very good data scientist if you're interested in that. If you're interested in becoming, handling huge amount of data, you can be a very good data engineer. So it's about like what you are good at, what motivates you, and then you can do that.
Thank you, sir. So I also have one question.
Yeah, sure.
So if someone wants to start learning this and is
Mhm.
totally unaware of how it
Mhm.
works, so how we can
Mhm.
start it?
Yeah, I mean, that's a very good question. I mean, I'll appreciate that you asked that question. So I wanted to cover that in this slide, but I actually missed out. So yeah, so see, first and foremost, you will have to get to understand like what data science is, what machine, like whatever I told you, right? So you can just go to YouTube or Google, just Google it out to understand what these concepts are. Once you do that, the best place I would say is to go to Coursera and start doing uh, courses on Coursera, because those courses are, you can do it on your own time, right? So you can sit there, you can go through the courses. And also if you think that okay, you will have to go deeper into it, you can uh, go to colleges who have these courses, and you can enroll yourself there. So these are the steps you can do. But if you want to be a self-learned man in data science, which is possible today with Coursera and very good online courses which are available today, you can do that. You just have to follow step by step, and you will reach your destination.
Yes, sir. So there's another question that
Mhm.
what kind of level or brain do you need? You need to mug up something, or you need to have a good background for it, because this seems very hard to me.
See, I mean, there are two types of things which is happening here, if you understand. So, for example, you can be an person who applies data science, and you can be a person who understands and applies data science. But the good part is that once you start applying data science, you start learning that as well, right? So, uh, I'll tell you that if you don't think that okay, I'll have to have this kind of a mathematical knowledge or statistical knowledge to start with. You can start with zero. You can go and understand the basic maths and the basic statistics behind it, right? You can go and take some courses to understand, because right now what's happening is you don't have to go very much deep into deep learning if you want to implement, if you want to apply it. Application part is a bit easier than understanding part of it. But once you start applying it to problems, reiterating over it, experimenting over it, you will learn and learn. It's more about the interest part. So once you will find it interesting that okay, you are going to predict something, forecast something, I mean, it's kind of a thing that is very new in the game, right? So you gain more interest, and then you learn more.
Thank you, sir. So there's another question from
Mhm.
Prachi Pandey. So
Mhm.
I want to create AI chatbot, but I don't know from where I should start. So can you guide her?
Yeah. Yeah, so I can just give you a direct answer that you can use natural language processing, but I'll give you a very structured answer that first and foremost, you should do some exploration that what are chatbots, like how they are built, what kind of techniques are used to build chatbots. Once you go to that stage and you understand, okay, this is XYZ is needed to build a chatbot, then you can just start searching for how can I make a simple chatbot, right? Start from the simplest chatbot you want to build, right? And then get your hands dirty. So I think if you just search on YouTube how to I want to create a simple chatbot, you will get hundreds of videos on YouTube. If you go to Coursera, you will find some courses on that. Take those courses, understand what you want to do, and then start building it. Start it. Yeah.
Yes, sir. Thank you, sir, for this lovely session, and it was very informative. I think we don't have more questions now.
Awesome.
Seems like hidden it was like bounced to them, but it was a very great session, sir. Thank you. So now I request everyone to turn on their video, as it's a ritual of Brats to take a group photo. Please,
Wow.
everyone.
I would like to just add one thing. Ashish, it was an amazing session from a layman's perspective. I am not a engineering student or a technical student for that matter. So for me also, this session was quite interesting to know, how basic things have been done to understand the entire process. So thank you so much for this wonderful session.
Thanks a lot. I appreciate it. Had a good time with everyone.
Yes, exactly. I mean, I was like, oh wow. I mean, so much is happening now in terms of technology. So that was very nice.
Thanks.
Are we done? Okay. Thank you so much, Ashish. Look forward to the next session with you soon.
Yeah. Thanks a lot, guys. I mean,
Thank you, sir.
have a good night. Bye.
Yes. So bye guys, stay tuned for the next session, which is happening on Wednesday, which is a series 3 of emotional intelligence. So it's at the same time. Log into YouTube and Zoom for more updates. Bye.